All right, let's look at the next example. 2 times the square root of 48 minus 2 times the square root of 32 plus the square root of 75. So let's go ahead and list the prime factors for each of these. Okay, so let's look at 48. We branch off 6 times 8. Branch off 6, we have 2 and 3. We're going to branch 4, 2 times, excuse me, branch 8, we have 2 times 4. Then branch 4, 2 and 2. So those are the prime factors for 48. For 32, we have 4 times 8. Branch off 4, 2 and 2. Branch off 8 again, 2 and 4, and then 4, 2 times 2. And then 75, we have 25 times 3. Branch off 25, 5 times 5. Okay, so those are the prime factors for each number that's under the radical sign. So let's look at 2 square root of 48. That's 2 times the square root of 48. Let's go ahead and list the prime factors. We have 4 2's and a 3. Let's go ahead and simplify that one. And then we're going to, because it's square, we have 2 sets of 2, or when I say because the index is 2, we're going to look for pairs. So we're going to bring 2 2's out, multiply it to the 2 that's already there. That gives us 8. What's left under the radical sign, square root of 3. Minus, let's do the next one. We have 2 times, and we have the square root of 32. And we have 1, 2, 3, 4, 5. 5 2's. And we're going to branch off there. Well, we branched off. We're looking for pairs. We're going to bring 2 2's out, multiply it to the 2 that's already there. That gives us 8. What's left under the radical sign? The square root of 2. And then we have the square root of 75, the prime factors. We have a 3 and then 2 5's. Circle your pairs and bring the 5 on the outside. And then we have plus 5 square root of 3. Then let's look and see what we have now. We have 8 squared root of 3 minus 8 squared root of 2 plus 5 squared root of 3. We want to circle the like terms or the like radicals. Those are our like radicals. So let's bring them together. 8 squared root of 3 plus 5 squared root of 3. Bring down the minus 8 square root of 2. They are not, it's not like, but we're going to add the terms that are like. And we're going to add the square root of 3's, which we have 8 as a coefficient, 5 as a coefficient. Add those together and we have 13 square root of 3 and bring down the minus 8 square root of 2. And there we go. Next example. We have 2 square root of 2x cubed plus 3x square root of 50x. Okay. So let's do this. Let's list the prime factors for 2x cubed. Okay. So because of time and everything, I'm not going to branch, or I'm not going to show the prime factorization tree for every question, but I want to I'm still going to show you using the prime factorization method. So for this number 3, we have 2 times. Well, the prime factors for 2 would be 1 and 2. 2 is not a perfect square, so 2 would stay under the radical sign. And then, but we do have 3 x's. So any pairs that you have there, circle. We have a pair of 2's, a pair of 2's. We have a pair of x's, so we're going to bring the x on the outside, multiply it to the 2x. So our solution here is 2x square root of 2x plus, let's look at the next example. You have 3x's already there times the square root of 50x. The prime factors for 50, you have here 2, 5, and 5, because 5 times 5 is 25 times 2 is 50, and we have an x. Circle your pairs. We have a pair of 5's. We're going to bring that on the outside and multiply it to the 3x, and that gives us 15x, and what's left under the radical, the square root of 2x. So we have several things that's going on here. You have like radicals, which is the square root of 2x, and then we also have like terms. So taking out the coefficients, we're going to take out the 2x and the 15x. Just for a second so that you can see this. Here we have like terms. So this question combined like radicals as well as like terms. So we know what to do whenever we have like terms. You're going to add the 2 and 15 and keep the variable the same. So then 2x plus 15x would give us 17x, and then we're going to keep the common radical, and that is the square root of 2x. And there we go. That is our answer. There's nothing else that we can do here. Next example, we have here the cube root of 81x minus the cube root of 192x. Okay, so 81, we're looking now this time our index is 3. So I'm gonna for this question, because it's the index being 3, let's go ahead and write the prime factorization. So let's look at just 81 for a second. We're going to break down 81, 9 times 9. Branch off 9, we have 3 and 3, and 3 and 3 again. Okay, so our focus will be on the cube root of 81 and 81x. So let's go ahead and write the prime factors. The cube root, we have 4 3's, and we have an x. So you're going to group in triples, groups of 3. So we're able to group one set of 3's. So we're going to bring that on the outside. And then that gives us 3 times the cube root of what's left under the radical sign, 3x. Then I'm going to put minus. And let's look at the cube root of 192x. Let's just look at 192. And let's write the prime factorizations. We have here 2 times 96. I'm going to break down 96. We have 3 times 32. And we have 4 and 8. And then I'm going to write it up here. 4 and 8, you have 2 and 2. And then 8, we're going to branch off 2 times 4. And we have 2 and 2. So here are the factors of 192x. How many 2's do we have? 1, 2, 3, 4, 5, 6. So that would give us, let's go ahead and write this 6. And we have a 3. So 2, 3, 2, 2, another 2, another, okay. And then we also have x. And because the index is 3, we're grouping in triples. So we have 2 sets that were circles, so we're going to bring out both 2's. And then on the outside, we have 4. And then what's left under the radical, we have the cube root of 3x. Now we have like radicals. The index that is the same. The radicand, that's the same. Okay. Therefore, we're going to subtract 3 and 4. And 3 minus 4 is negative 1 cube root of 3x. So that is your solution. But remember, in MyMathLab, do not put the 1 there. So you want to say negative cube root of 3x as your solution.